Thank you. It's weird when I have teammates sitting in the audience. First of all, thank you so much. Okay, cool. So today we're going to talk about AI project lifecycle, because when we work with the clients, they see AI algorithm, and we speak a lot about algorithms, but it's more on the business side of how that algorithm or how that project is going to be integrated into some product or all the questions that we should ask. So we're going to go through step by step of main parts in general case. What we found out to be great questions, of course, they are not all the questions because I have time limit for today, but to navigate your decision making on how to go through each process or each step of the product. And generally, it looks something like this. We have some idea. Client goes and says, hey, my neighbors or my competitors are doing this thing. Let's do it. Or there is actually top-down or bottom-up approach and say, okay, we need this. Doesn't matter. Then we said, cool, let's train an algorithm, then test it on some test set. We do all proper things. Please welcome. And then there is a complexity in deployment. We don't see many things, so they decide to scrap the project. To give you an example, one client, not ours, decided to go with the recommendation system. They didn't see ROI in 1 year because it's a recommendation system. It's kind of normal. And they said, okay, this is not going to bring any value to my company, so we're going to scrap the project. They did. They invested about 8 months in development, stop the project. Or they do something like this. When you have more money, you invest more money, and then decide, okay, let's scrap the project. It's generally the real project looks something like this. Maybe some of you seen this picture. It's not mine. It's a bit older, but I found the best illustration to be something like this. So there is some need. And a lot of companies today, especially, because we are in the AI hype, coming with the need of AI, just for sake of it. It's not a good need. We need to have some problem to solve it. And AI it might be a solution, might not. So we start with some need. After that, we start collecting data. So everything goes around the data process. Labeling the data, and then a lot of companies stop here because they don't see how expensive it is to find a good data set. We are working with one company where the data set is not great. Okay, we are currently in that stage. And then we potentially create new features. Then goes the model training, model evaluation, and maybe model deployment. Why maybe? Many times you will see from model evaluation that you need to circle back. You need to collect more data. You need to set new metrics. You need to find out, wait, are we actually solving for the right thing? We talked about metrics, and maybe most of you here in the audience are coming from a technical background. And when we solve from a technical standpoint, we have the one accuracy metric, or maybe mean square error, or something that we can optimize for. But that is not important for the business. We need somehow to connect that metric that we are optimizing our algorithm to actually business KPI, what we're actually trying to solve. What is the need? If we go with that, we are serving the model monitoring, of course, and then maintenance. About 80% of the projects fail here because either they're not communicated well in the beginning that, hey, we are actually at the beginning when we start deploying the first model, we are not finished with this. So many times they don't see what's actually going to happen. They don't see the resources that they need to invest after we start putting first or second model in the production. They see the research process, and yeah, that's 6 months, 8 months, 1 year, maybe 2 years, really depends. And they don't see that this thing that's done. We have the trained algorithm, it's amazing, it's 95% accuracy. data scientist told me. It's the best algorithm ever. But then the maintenance kicks in. So you need to pay the cost of servers. You need to pay the cost of people that are going to maintain that project. And that's about 80% of today's project why they fail. They don't see that. So let's go over each of these steps and go over the questions or things that we need to think about. In the data collection process, and in this stage, the very beginning, can happen a lot of things. And the first question is, of course, the logical one. Can we access this data? Now, if you work with the healthcare, there are many more questions related or sub-related to this one. Can we actually maintain the data in moral standpoint? Do we need a lot of patience? Can we actually create artificial data? So all of this is related to this very step. Now, because of the GDPR, you might have a lot of data, but you can't use it. It might be stale. So, to give you an example, a client came about a year ago and said, okay, we have about 100,000 images for some task. They completely changed the surroundings from the task that we're trying to solve. And from that standpoint, they had only about 10,000 images collected in the new system. So yeah, they had physically 100,000 images, but these 19,000 images are not usable for the training that we want to do. So they actually have only 10,000 images. So if you change the system, if you change the surrounding, you can't use all the previous data. Another example, COVID. Yes, I don't want to use that term anymore, but if you're a training recommendation system, user needs are actually completely changed before and after. So if you had an amazing data set before COVID happened, you don't have the same needs. And especially in the meantime, when that actually was happening, completely different way of interacting with the website. 3 of our clients saw that. And now, of course, the question is, do we have enough data? And clients always ask, okay, sure, I would like to do this, but actually, do we have enough data? Before the experiments, you can't really find out about this, but that's a valid question. Now, if you don't have enough data, how fast can you acquire more? And recently, one client came to optimize for their support, and they had about 20,000 emails they would like, chain of emails that would like to use as a training set to replicate basically the base answer that their support would give. Then we entered the data set, and what I found out is this. They had 2 different ways of interacting with their clients, through email that they would like to automate, and the second part is via phone. Normal stuff, right? And then I entered their data set. The answer to the really specific question was, it's exactly what I told you on the phone previously. That was the email. And I said, okay, that might be the one case. It's not really the most common. No, it was. About 3 in 10 mails were basically in that context. So they need to collect more data. And then you have 2 options. To either change the process, which in most cases it's not possible, or just see how much inflow of the data you have, change the way that they answer in the meantime, and then approximate how long it's going to take to collect more data. For that client, it's about 6 months. So after that, can we use the data? We're currently working with one client where it's a lot of duplicates, a lot of really intertwined data sets that are basically not usable in a way that we wanted it at the very beginning. So we needed to change a lot of ways to be creative, basically. So if you are missing some points, if you have a lot of duplicates, you need to handle this, of course. There are sometimes delayed labels or labels that are not really right, they're not really correct, or biased in a way that you didn't anticipate for. So everything can happen in this case. Now, problems that are most common in this stage is find out that it's too expensive. If you need to replicate one example and it takes maybe $100, it doesn't sound much, but then you find out that you need 10,000 of those. So it actually adds up, and it's expensive. And then people stop everything. Poor label or data quality is a really big issue. In one company where I previously worked and led their AI team, we had about 120 data labeling personnel. And they were labeling data sets about 4 million images per week. That was the inflow. And we found out, we trained an algorithm, we did a lot of great jobs. But then, later down the stage, we found out that about 10% of the data was completely wrong, wrongly labeled. Why? Well, the original process of the labeling was 6 hours of constant labeling. We didn't measure the drop-off rate of when the concentration of them actually falls down. And we found out that the submission of the labels are really worse after 4 hours. We hire more people and decrease amount they work to 4 hours. We handled that at the beginning, but then we needed to relabel all the 10%. So we could train the best algorithm ever, and we did, but later, because we had about 10% of completely wrong data set. We have, as mentioned, outdated examples, and of course bias. And bias can happen all around us. And you can have inconsistency in labels that might be due to bias. But if you have biased consistency, it might be okay. To give you an example, in one startup that I consulted, they had 2 labeling personnel, and one of the labels they needed to provide was size, which was fine, and then the color. We didn't find out later that one of them was a bit colorblind. So it was completely wrong. Well, not wrong, I would say, but if you use this and this part of the labels, you can't train that. So if you give all the labeling to the colorblind person, it's completely okay because you have consistency in that. And you don't have in these 2 cases. So how we change that? Well, we gave the size to colorblind, and color was with the other. Change the whole labeling process. Now, these are just some of the questions that what we consider a high, sorry, something happened here. Some menu came, I can change the slide. Okay, good, thanks. So, what we consider a high quality data set? Well, of course, complete information. If we are missing some information, we can't use the data set. To give you an example, one of the cases that we tried to solve in the past was to create an optimized user experience for one client. What I mean by that is change the interface based on their preferences and stuff like that and learn from them. But then we needed a lot of information about their user base because that actually we correlated that with their needs. And what we found out that the original part of the registration process in their application was considered to be optional for most of the places where they needed to provide, for example, location, age, and stuff like that, okay? And they changed that. They changed it recently before we started working together. And they had about 70% of the data, about 74, that had the optional registration process, and then about 26% of the data that actually were registered based on the new. So they had completely misalignment. So what they needed to do, either use only 26 to train, or provide just a user pop-up to say, hey, we need you to provide this information. We can't fill in this for them, right? Now, balanced and good coverage of the labels. And then, of course, production grade samples. What do I mean by that? If you're gonna see completely different, let's say you're training for face recognition, and you're training all the time in one space, and then you have these lights that are reflecting on my face in the production, well, it's gonna change the way that my face is seen on the camera. So we need these types of examples as well. When it comes to model training, decision before that we need to make is make sure that we have all the previous steps, that our data inflow is actually correct. Most of the times, we'll see that actually processing the data to the moment of training is causing a lot of mistakes in the data. Then, it's really important to define what we are measuring against. We can't just blindly say, okay, we are just training the algorithm. What is the baseline? What we're trying to compare to? If we are trying to choose the baseline, you can go from user human-based performance, or just put all zeros. I saw companies do that as well. It's not the best, but it can be a starting point. It can be previous system, or previous machine learning algorithm if you had one. So anything that you choose is valid as long as you compare something against that. Okay? You don't know where you're progressing. And then that metric needs to be exactly connected to some KPI, business KPI that you're measuring. It's not hanging around and say, okay, we have 64% accuracy. It does sound bad, but you're maybe performing really well in a business environment. It really depends on the context. And optimizing more than 64% might be wrong for you. Okay? Then we need, of course, to create subsets for the data set testing and training. It really needs to, in most cases when we are looking for courses online, they would use train test split, and that's fine, let's use that. In reality, that's the worst that you can do, because you don't really know what's actually happening in your test set. And the test set should and must replicate what's happening in production. In the company where I mentioned that we had 120 labeling employees, persons, we had 2 engineers full-time working on creating and managing test set. They worked directly with users and directly with my team to make sure that they are replicating exactly what user will do and use in production. When it comes to model evaluation, I mentioned a couple of times this. In most cases, well, we need to decide how we're going to measure. In most cases, you're going to be offline measuring that. So you have some delay. But if it's online, sure, that actually creates a lot of troubles as well in that deployment standpoint. And then you need to make sure that you are actually connecting those metrics, whatever that metric might be, to the KPI that you're trying to solve for. That comes from business. A lot of things and a lot of discussions that I'm having with clients is, their presumption is, okay, so I have AI project. It's an IT project. Some IT guys will do that. They delegate, they're not included. Okay? That's wrong. We can't do the part of job that is actually connected to us, which is engineering part. But then, who's going to use that? We need people from around the process that's going to be interacted with. For example, we are working with HR automation. We need HR people to be included every day with us to make sure that we are actually solving their problem. What we did, we are catching up every day. On our daily, at least one of their HR guys comes in and checks what we are working on. We detected a lot of issues from our side because we didn't understand them. So we could optimize for basically us in the vacuum and say, yeah, that's fine, like it's working really well. But then you're giving that to the user and you find out they're gonna not use it. So you need actually business people or people from around the company, depends on where you're trying to implement your AI solution, to be included in the development process, not after. After is sure, but in the process of doing that. Before, in between, and after. All the way. Now, it always comes to the process of ethics. Not all the cases are going to be connected to this, but you should even consider seeing if there is something that we need to ask ourselves in the process. And of course, evaluating for, not directly for ethics, but robustness of your algorithm, are you actually covering all the cases that might happen, or most? If there is bias in your data set and you're aware of it, that's okay. You're gonna solve that along the way. It shouldn't stop you, but as long as you are aware of it. If you're not aware of that bias, that's the problem. That becomes the problem. As simple as, let's say, one company for pet store, basically, create an algorithm from US to, based on the image of your pet, they're gonna tell you which items you should buy. That was the case, basically. You take a picture, get items. And they trained. They trained starting from cats and dogs. There is a public data set. We potentially all even see or use it. Sure, they started from that data set. But the problem with the data set, the public one, is they have all the dogs in nature and cats in house. Just check it. So what happened to them in production, user takes out their cat on a leash. That's a new trend, I didn't know, but it is. They're hanging out with their cat in park, take a picture, and it's a dog. What happened? Well, algorithm didn't look at cats and dogs, they looked in the surroundings. You can't really isolate if you're not aware. So they see the tree, it's a dog. They don't really consider a cat or a dog. Now, when it comes to production, in most cases you will have at least 2 models, at least. And when you deploy one, you will have multiple versions of the new model to compare against the baseline, which is your model in production. Baseline changes. So you need a way to test between a couple of models to see which one, or should you put a new model in production. And when it comes to that, well, then we decide, okay, let's go with the new model, or let's stay with the last one. So when it comes to model deployment, there are 2 ways to achieve this. Well, static deployment, where you would go and deploy it together with the system that you're trying to solve. It can be on edge, it can be computer application, whatever, but you're deploying with that. And then you have dynamic deployment, which is mostly on the cloud, let's say. Depends on what you want to do, and depends on what you're maximizing for. Either one might be the case for you. For the company that I mentioned, we had all on-edge devices. We reached 200 million users. That was the worst for us, because it was scalable. You had many different applications, many different versions of the mobile phone, sometimes older. So the production inference time takes about 8 seconds. The new phone takes about 2 seconds. So user experience is not uniform. You need to change. And then what is the strategy to deploy? Are you going to roll out everything in a single deployment? Or are you going to do the silent deployment or shadow deployment, which is amazing when you have the baseline model and you try to compare the new against the old, but you're not certain that you want to push it to the users. So what you do is basically constantly make predictions with the new and the old one, send the old predictions, but the new just take for yourself and see whether or not is good one. And then canary deployment or multi-arm embedded is fine here. In the case of the previous system, we did canary deployment. And think about this when you are deploying. Is it easy to deploy or maintain? Have you tested end-to-end? And the speed of full request. For monitoring sake, there are many things that can happen in production. Data drift is quite normal. Data staleness or model staleness is also normal, and that's where the maintenance comes in. That's why people think that when I have the model, it's done. But then you need to constantly retrain it, reevaluate it, collect more data, user behavior changes, user interface changes. So you need to do all of that to battle the data drift or model drift. A couple of different things that are model drift that can happen. It's an instant, spontaneous, periodic drift. For example, a lot of in tourism, you have periodic drifts where you have, for example, summertime, where user behavior completely changes. So all of that should be and must be considered in production. And then just a couple of things that can happen. You can read it through or take a picture. And then back to this. Thanks.
Thanks.